So to solve this linear equation, what we need to do is first off remove the parentheses. So what I'm going to do is distribute the 8 through, distribute the negative 3 through. That leaves me 3x plus 8x minus 32 minus 6x plus 3 equals 0. Now I'm going to combine my like terms. Well, I've got a 3x, an 8x, and a negative 6x. That combines to give me 5x. And then I've got a negative 32 and a positive 3. That's negative 29. That's still equal to 0. I'll add 29 to both sides of this equation. And then I'm going to divide by 5. And so it's 29 over 5. And that's just obnoxious enough. I don't want to go check it. So to solve this system by linear combinations, what we want to do is be able to add these equations together and get rid of one of the variables temporarily. I'm noticing this is negative 10y and that's positive 20y. If this were negative 20y, that would combine really nicely. So what I'm going to do is I'm going to multiply both sides of this equation by 2. So I'm going to rewrite the first equation. So 10x plus 20y equals 20. And then the second equation becomes negative 2x minus 20y equals 12. Now I'm going to combine those. I'm going to get 8x, the y's are gone because that was what I wanted, 32. So divide by 8, x equals 4, we think. So now I'm going to go back to one of these two original equations. I'm going to use the second one. Negative 4 minus 10y equals 6. I'm going to add 4 to both sides, so negative 10y equals 10. So it looks like y equals negative 1. So I think 4 and negative 1 is the solution. I'm going to go back to my other equation that I didn't use to check. So 4 times 10 is 40. Negative 1 times 20 is negative 20. And that does equal 20. So that checks. That's the solution. So for this equation, I'm seeing a double root at negative 1. I'm seeing a triple root at positive 2. I'm seeing a single power root at 4. And I'm seeing a y-intercept at negative 4, or 0, negative 4. So the first thing I'm going to do is I'm going to write y equals some stretch factor a. I don't know if there's a stretch factor yet, but I'm going to insert it in there. And then since this is a double root because it bounces, I'm going to have x plus 1 squared. Now because this does a wiggle instead of a bounce, it's not a straight pass-through like a first power. So I know that's a triple root. I mean, it could be a fifth power root, but we'll keep it easy and call it a triple root. So x minus 2 cubed. And then that last fourth degree, when x equals 4, it's a single power root. And then I've got this y coordinate of 0 and negative 4. That will let me decide on the a. So when x is 0, every place I see an x, I'm going to substitute in 0. Then y is negative 4, and then I'm going to solve for a. So negative 4 equals a times, let's see, 1 squared is 1. Negative. Now if I substitute in 0 for x, that becomes negative 2, and negative 2 to the third power is negative 8. And then I'm going to replace this x with 0, and 0 minus 4 is negative 4, so and that's not being raised to a power, so that's negative 4. So that gives me negative 4 equals a times positive 32. So I'm going to divide both sides of this equation by 32. I wrote 33. 32. I'm going to divide by 32. Negative 4 over 32 simplifies to negative 1/8. So my final solution is y equals negative 1/8 times x plus 1 to the second power times x minus 2 to the third power times x minus 4. And that is a polynomial that will give me this graph. Solve this using fractions. So what I'm going to do, because I've got mixed numbers, as they taught you back in elementary school, I'm going to rewrite this to improper fractions. And I'm going to use that. I know 1 is the same as 3 over 3, and the easy way we learn to do that is do 1 times 3 plus 2. So that's negative 5/3 times, and I'll do the same thing with the next one. 2 times 3 is 6 plus 1 is 7. So negative 7/3, negative 7/2, sorry. The next one becomes negative 4/3, and the last one's already 3/2. So then what we can do is, let's see, that 2 cancels that 4 to give me a 2. That 2 gets rid of that 2, so now we've got 1s. That 3 goes into that 3 once. And I see 3 negatives, so I know my answer is going to be negative. And I don't think anything else cancels out, so 7 times 5 is 35, and 3 times 1 is 3. So that's what that becomes, fractions. So we're going to find the slope. I want a linear equation, so I'm going to call this x1, y1. I'm going to call this x2, y2. So 12 minus 3/4 over negative 1 minus 1. Well, 12 minus 3/4 is 11 1/4 over negative 2. And since I really am doing is I'm taking 11 1/4 and dividing it by negative 2, I'm going to treat this like fractions. So this first fraction becomes 45 over 4 times 1 over 2. And of course that's negative. Nothing cancels. So my slope is negative 45 over 8. And then I can choose either point to make my point slope form. So remember, it's x, y. So I can say y minus 3/4 equals negative 45 over 8 times x minus 1. Or the other way you could do this is to use the other point. So y minus 12 equals negative 45 over 8 times x plus 1, because it's minus a minus 1 there. So those are the two answers you could have. This is an exponential equation. I know that x and y, as we did back in the beginning of chapter 4, we can say that 3/4 equals a times b to the first power. And we can say that 12 equals a times b to the negative 1. So I'm going to solve both of these equations for a and set them equal. So I'm going to divide by b. So that becomes 3 over 4b. This one is 12 over b to the negative 1 equals a. Well, b to the negative 1 can be written as 12 times b. So then I'm going to say 3 over 4b has to equal 12b, because if a is the same in both equations, I can set them equal. I'm going to write the cross products. So 3 equals 48b squared. So then I'm going to divide both sides by 48. So 3 over 48 equals b squared. Well, 3 over 48 is 1/16. And then if I take the square root of both sides, that tells me b equals 1/4. And then since I know that a, if I go back up to this equation here, right, since I know a equals 12 times b, 12 times 1/4 equals 3. So the equation is f of x equals a times 1/4 to the x power. And that's an exponential equation that goes through those points. So to find percent of change or percent of discount, the new price is $2.99. The old price is $379.95 divided by the old price of $379.95. And I'm going to multiply that by 100 to make it a percentage. When I did this, I got 21.3%, and of course it's a discount. This is another half exponential growth problem, and I know that if I think of this as y equals ab to the x, it's one way to do it. I could also think of this as y equals ae to the kt or kx, and I can do either way. I'm going to choose to use the ab to the x method. So I know the half-life is 3 days. So I know that when I take y divided by a, it's going to be equal to half. So how much pocarium is left divided by how much it started with, it should be a half. So 1/2 equals b to the third. Now I can use logarithms to solve this. So No, actually I don't have to use logarithms to solve this. Sorry. I'm going to take the cube root of both sides. So the cube root of 1/2, when I did this earlier, I got 0.7973. So since I know that y equals some initial value times 0.7937, I think I said that wrong, to the x power. So that I've got. Now I've got to find a, the initial amount. So they're telling me 20 days, which is x. There's 52 milligrams remaining. So 52 equals our initial value times 0.7937 to the 20th power. So I'm basically going to take 52 and divide it by that number, whatever that number is. Okay, that'll tell me what my A is, and I came up with A being equal to 5,282.9. I mean, I could do some rounding there. So that leaves me an equation of y equals 5,282.9 times 0.7937 to the x power. Then they're asking us how long till there's only 22 milligrams remaining. So if I say 22 equals 5282.9 times 0.7937 to the x power, I'm going to divide both sides by the 5282.9. That gave me 0.00416 equals that base raised to the x power. Then I can take the logarithm of both sides. That'll get the x out of the exponent using that exponent property. So basically what I'm going to do is I'm going to divide to find x. I'm going to take log of 0.00416 divided by the log of 0.7937, and I came up with 23.723 days is that amount. So we've got, let's see, let's highlight what I need. So there's the initial amount, and here's how many days. But of course you have to do all this in-between work to get there. So another log equation in order to get the exponent. I can't rewrite this as, I mean I could rewrite it as a log. I think what I'm going to do is I'm going to take the logarithm both sides, then use that exponent rule, that power property for logarithms to bring that exponent down in front. Then I'm going to divide both sides by the log of 4. Then I'm going to add 3 and divide that answer by 2. And when you're all said and done, we're going to get, let's see, where's my work here? I came up with x being equal to 2.865. Okay, going back to the first part of this last semester, really, here with this one, I'm seeing an absolute value graph. So first off, let's talk about domain. I'm seeing this graph, this part of the graph goes from -4 to -1. So it doesn't really matter, I mean, because I didn't really specify what's closed, what's open. So I'm just going to make both of these closed, which will require me to leave this one open on that side. So anyways, what I'm seeing a reflected absolute value graph. I'm seeing the vertex of that absolute value graph is shifted left 3, up 4. So I know it's going to be absolute value of x plus 3 plus 4, but it's been reflected, so I know that the leading term has got a negative in front of it. And I'm also seeing a slope of 2, not just 1. So I know it's down, it's negative 2. So that's that part of the graph. For this part of the graph, I'm seeing a reflected parabola. It looks to me like x squared has been shifted up. So negative x squared, to get it reflected, plus 1. And I'm going to call that open on negative 1, closed on positive 1. You could leave these both open. That part doesn't really matter, as long as one of these is open and one is closed. Because you can't have two values, two functions at the same point. So then the last one here, I'm seeing a square root graph, and it's shifted right 1. So the square root of x minus 1, and I'm going to use that graph on 1, 2, you could say infinity. I'm just going to close it at 4. So I hope that jogs your memory on how to do these kind of problems.